Today we're going to do objective 15, which is to factor by GCF. What does GCF stand for? Greatest common factor. Very good. Okay, so this is your first example. And it says 2x, and then in parentheses we have 3x plus 8. Okay, so we're not going to actually factor this out. We're actually going to do what right here? Distribute? Is that what we're going to do?
Yep.
We're going to
work this problem. Distributed. So we're going to take the 2x and multiply it to the 3x, and then we're going to multiply it to the 8. So 2x times 3x would be 6x squared. Very good. And 2x times 8 is
16x.
plus
Very good.
16x. Very good. So what we're going to do is that's what we did last week. We multiplied a monomial times a binomial, follow me, and we got an answer. What we're going to do today, What we're going to do today is I'm going to give you the answer. Okay, so we're going to start with the answer, and we're going to work backwards into the two things that multiply to be this. So, for example, if I said, give me two factors of 6, what would you give me? Give me two factors of 6. 2 and 3. Very good, because those are two things that multiply to be 6. So if I said, factor this binomial, I want you to take the binomial and I want you to give me the two polynomials that multiply to be that. Does that make sense? And the way we're going to do this is by taking out a GCF. We know GCF to be greatest common factor. So here's what we're going to do is I'm going to look, and in elementary school you made the little factor trees, right? Or you listed all the common factors of this number and all the common factors of this number, and then you went and circled the ones that match, and then you picked out the biggest, right? I'm going to assume by now that you can look at me and tell me the greatest common factor of 6 and 16 is, what's the largest number that can go into 6 and 16? Is 2. Does that make sense? Is 2. Okay, so we're going to take a 2 on the outside. This has 2 x's. This has 1 x. What's the largest I can take away from both? I can take out an x. Okay, and I'm going to put that on the outside of the parentheses. And what I'm going to do, so I'm going to take the, and someone said, do you always put the GCF, the greatest common factor, on the outside? Yes, you take the GCF to the outside. And what I'm going to do is I'm going to take out, and when I say take out, I mean divide. Does that make sense? When I divide, I have 6, and I'm going to divide out a 2. What am I left with? A 3. If I had 2 x's, and I take 1 x out, I'm left with a 1x. If I had 16, and I divide out a 2, I'm left with 8, and if I had an x and I take out an x, how many x's do I have left? I don't have any x's left, right? You had 1, you took 1 out, we know how many left. And so look, this is your answer. Didn't it match what we did? We just worked it in reverse. So again, instead of me saying here are the two monomials or polynomials, multiply them and get the answer, we're going to work backwards. I'm going to give you the answer and ask you for the two things that multiply to be that. Okay? So in this case, what's one of the factors? What are the two things being multiplied? It is a monomial times a binomial. So what's one of the things being multiplied? A monomial, which is 2x. That's one factor. What's the other factor? What's it being multiplied by? A binomial. 3x plus 8 is your other factor. These are the two factors, like 6 and, or what did you tell me? 2 and 3? Okay, these are the two things that are being multiplied to give you the question. Okay, those are the two factors. Any questions on that? Oh, yeah. Any questions? Okay, so let's look at another one. So does everybody understand the concept of what we're doing? Yes. Oh, I'm so glad you asked that. Logan said, couldn't we take this and check it by multiplying 2x times 3x is, and 2x times 8 is 16x. If you take your answer and multiply it, you should get what you started with. Awesome. And I recommend that you do check it. Okay, I do recommend that you do check it. Today will be pretty easy. We're working with taking out a GCF. So we're working with the monomials. And we know anytime we're working with taking out just one term, it's pretty simple. Next week when we get into the reverse of FOIL, like how do we multiply binomials? FOIL, right? So when we do it backwards, you follow? And work the reverse of it, as it gets more complicated, I'm going to really want you to check it. So I'm going to require a check step next week. I would like a check step today, but I understand that this is pretty easy. So if you feel like you're okay without the check step, but I would always recommend, better safe than sorry, let's check it. Okay, so very good. Yeah, you could just multiply it back and make sure that you're right. Okay, all right, so let's take a look at this. Example 2. So I want to factor this trinomial. I want to find out what two polynomials multiply to be that. Okay? So, numbers with numbers, a's with a's, and b's with b's. What is your GCF of 4, 8, and 2? 2. Very good. So we can take a 2 to the outside. And again, you're going to take the GCF to the outside. Okay? We have 2 a's here, 1 a here, and 1 a here. What's the largest number of a's that I can take away from each? I can only take 1. I can take 1 from there. Everybody agree? How many would I have left? 1. I can take 1 from here. How many would I have left? None. I can take 1 from there. Could I take 2? Because you always want to take out your greatest. Why couldn't I take 2? Could I take 2 from here? I could take 2 from the first term. Could I take 2 from there? No, that only has 1 to take. Okay, so in this case, we can only take out an A. I've got a B here, 2 B's here, and a B there. What's the largest I can take from each? I can take out a B. Very good. How many blanks would I have? Why 3? Because it's 3 terms. And I encourage you to draw the blanks because that will remind you to put something in those blanks. Does that make sense? Okay, so when I divide out a 2 from a 4, I'm left with 2. 4 divided by 2 is 2. Okay, if I had 2 A's and I take 1 out, I'm left with 1 A. If I had a B and I take it out, I'm left with none. If I divide out a 2 from an 8, I'm left with 4. If I had 1 A and I take it out, I'm left with none. If I had 2 B's and I take 1 out, I'm left with 1. And in this case, if I take a 2 and an A and a B out, and again, when I say take out, I mean divide out, 2AB divided by 2AB is 1. The question is, what do I put in the blank? Do I put a 1? Why do I have to put the 1? Because it'll change my answer because I'm adding or I'm subtracting. And remember when I say, when do you have to write those 1s? When you have a headless fraction and when you're adding or subtracting. And in this case, the 1's all by itself and the 1 must stand alone. Does that make sense? When you have a 1, when you're adding or subtracting a 1 and it's by itself, you got to write it because it will change your answer. Okay? And I do agree with Logan. You could take the monomial and distribute it back just to make sure that you end up with this. Okay, the trinomial. So tell me this. What's one of the factors? The monomial. Very good. 2AB. That's one factor. What's the other factor? The trinomial, 2ab minus 4b plus 1. Why do I keep asking you what's one of the factors? Because on the SOL, like what if I said, give me one factor of 12? What would you say? 12. Yeah, 12 is a factor of 12 because 12 goes into 12 one time, right? So on the SOL, sometimes they might say factor this completely, which means they want the whole kit and caboodle. They want the whole thing, right? What times what is that? Okay, what are the factors that multiply to be that? But they might just say, what's one factor? And so they might only, so if they just said, what's one factor, you could say the monomial, or you could say the trinomial. You with me? You could say 2ab, or you could say each one of those is a factor. Those are the two polynomials that are multiplying to be that trinomial. Okay? Example 3 has a purpose. What's my greatest common factor? Don't I normally take out variables too? Sometimes you can take out numbers and variables, like we did on example 1 and 2, right? We took out some numbers, some variables. Sometimes you don't have variables that match, okay? And so in this case, the only thing I can take out is a 3. Sometimes you can only take out numbers, and then sometimes you can only take out variables. How many blanks would I have for this one? 2. And so if I divide out a 3 from each, I'm left with 5w minus b. And again, does everybody understand why I can't take out a w? Why can't I take out a w? Because they both don't have it. So let me caution you this. What if you had something like this? 2a squared plus 4a to the 5th minus 6. Yeah, that'll work. What would I take out from that? And you don't necessarily need to write this down unless you want to, but everybody agreed I could take out a 2. Yes? Could I take out any a's? Why not? Because not all of them have it. This guy right here, the third term, does not have any a's to take. So if they don't all have it in common, that's why they call it a greatest common, because everything has it, you follow? Then you can't take it out. Okay? Hint, hint, hint. You might see something like that today. So this has purpose. We're going to do our numbers with our numbers and our u's with our u's and our t's with our t's. What do you think our greatest common number is? Oh, I didn't get one by you at all. Was anybody going to admit to me they were thinking 7? No. I do agree. A lot of people would think 7 because they see 7 and they see 21 and they think 7, right? But what number is right here? What's the largest number that can go into 7, 21, and 1? 1, okay? So in this case, tell me this. What if I divide everything by 1? The same thing. So do I really need to take out a 1? No. So remember what I told you in the beginning? Sometimes you can take out numbers and variables. Example 3, we only took out a number. And in this case, we're only going to take out variables. I mean, you could take out a 1 in front of it, but the 1's not going to change it. Okay? So tell me, I got 2 u's here, 3 u's here, 2 u's there. What's the largest number of u's that I can take out from each? 2. And again, everybody, if you got to take out the largest number possible, okay, that you can take out from each. I got 2 t's here, 3 t's here, and 4 t's there. I can only take out 2. Why can't I take out 3, Brandon? Because of t to the second. Very good. This only has 2 to take. You can't take out more than you have. Okay, so you could take 2 from there, you could take 2 from there, and you could take 2 from there. What's the key to knowing how many variables to take? It's always the what? The smallest number that you got. Like you got 2 here, you got 3 here, you got 4 there. The largest you could take out would be 2. Okay. So if I take out a u squared and a t squared, what would I be left with in the first blank? 7 plus 21 ut minus t squared. Did I lose anybody on that? Everybody okay? Pretty simple? So I think I've shown you pretty much everything that is involved in factoring out a GCF. Sometimes you can take numbers and variables. Sometimes you can only take numbers. Sometimes, like this one, you could only take variables. I've shown you some where you can take more than just one variable out, right? What if I have an m to the 6th, an m to the 7th, and an m to the 4th? What's the largest number I could take out? You could take out 4. So you got to take out as many. What if you don't take out 4? What if I only took out 1 or 2? Then your answer's wrong. It's not fully factored. Does that make sense? You didn't take out the greatest common factor. You didn't take out enough. So make sure you take out the biggest. I've shown you what to do. What happens when you have like a 2t and you take out a 2t? What do you put in the blank? If you had a 2t and you factor a 2t out, 2t divided by 2t, you'd put a 1. So I showed you that. So again, I think I've shown you all the quirks about this. So let's just try some practice. On page 479, I want you to try 1 through 4 to begin with. Okay, let's try 1 through 4 to start with, and we'll go over those and make sure you feel good. 479, 1 through 4.